On August 30th, 2026, at 7:26 in the morning, a rocket will lift off from Kennedy Space Center, carrying NASA's next Great Space Telescope, 9 months ahead of its original schedule, aimed at a spot in space nearly 1,000,000 miles from Earth. And the mirror at the heart of it didn't start out as a telescope mirror at all. The mission is called the Nancy Grace Roman Space Telescope, and it's built to do almost the opposite job of the James Webb Space Telescope, which has dominated space astronomy headlines for the past several years. Where Webb stares deep and narrow, patiently gathering light from a tiny sliver of sky, Roman is built to see wide and to see it fast. Start with the mirror itself, because its origin story is stranger than most telescope hardware ever gets. Roman's primary mirror measures 2.4 meters across, exactly the same size as the mirror inside the Hubble Space Telescope. That's not a coincidence, and it's not really by design either, at least not NASA's design. The optics that made a mirror this size possible were originally built for a completely different purpose and were later transferred to NASA by the National Reconnaissance Office, the U.S. government agency responsible for spy satellites, a piece of Cold War-era surveillance hardware repurposed to help humanity look outward at the universe instead of down at the Earth. What makes Roma genuinely different from Hubble or from Webb isn't the mirror. It's the camera sitting behind it. Roma's wide-field instrument is a roughly 300-megapixel near-infrared camera, and it captures a patch of sky about 100 times larger than Hubble does in a single exposure at comparable sharpness, a region of the sky that would take Hubble 100 separate pointings, stitched together over weeks or months, to fully map. Roma can capture in one single shot. It's less a telescope built to photograph one spectacular object beautifully and more a machine built to survey the entire sky at speed, cataloging enormous swaths of the universe that would otherwise take a human lifetime to image, piece by piece. Roman also carries a second, more specialized instrument, a coronagraph, a device that physically blocks out the blinding light of a distant star in order to reveal the much fainter planets orbiting around it. According to NASA, Roman's coronagraph is at least 100 times more powerful than any similar instrument currently in operation, sensitive enough to detect planets roughly 1 billion times dimmer than the star they orbit. That's not just an incremental improvement. It's specifically meant to serve as a working proof of concept for an even more ambitious future mission, NASA's planned Habitable Worlds Observatory, whose entire purpose will be searching nearby star systems for planets that could actually support life. Two enormous scientific questions are driving this entire mission, and they're almost unrelated to each other, bundled together into one telescope, mostly because Roman's particular combination of speed and sharpness happens to be useful for both. The first is dark energy, the unexplained force that appears to be accelerating the expansion of the universe, one of the biggest open mysteries in all of physics. Roman is expected to survey on the order of 1 billion galaxies over the course of its mission, measuring their positions and their subtle gravitational distortions in extraordinary detail, tracing exactly how the universe's expansion rate has changed across billions of years of cosmic history. It's an attempt to build the most detailed map of the universe's structure ever assembled, specifically to hunt for clues about what dark energy actually is. The second major goal is exoplanets, worlds orbiting stars outside our own solar system. Roman will run an extended microlensing survey of the crowded inner region of the Milky Way, watching for the extremely subtle gravitational flicker that happens when one star's light briefly bends and brightens because an unseen planet orbiting a completely different star happens to pass almost directly in front of it from our point of view. That single survey alone is expected to turn up more than 1,000 new exoplanets. For context, it took humanity roughly 3 decades and the combined efforts of dozens of missions and observatories to confirm the 6,000 exoplanets currently known. Roman's microlensing survey alone could add nearly 20% to that entire historical total in a single dedicated observing campaign. There's a human story sitting underneath all of this hardware and all of these numbers, one easy to miss amid the technical specifications. The telescope is named after Nancy Grace Roman, who became the first woman to hold an executive position at NASA and who is often informally credited as the mother of Hubble for the role she played championing that telescope's development. Decades before it ever actually launched, Roman spent much of her career convincing skeptical colleagues and funding bodies that a space-based telescope, free from the blurring interference of Earth's atmosphere, was worth the enormous cost and risk involved. She didn't live to see this particular telescope named in her honor. She passed away in 2018, 8 years before its launch. But naming NASA's next major observatory after her connects 2 flagship missions, separated by more than 3 decades, through the same basic argument she spent her career making, that seeing further and seeing more clearly is worth building for. Once it reaches orbit, Roman won't stay anywhere near Earth. The telescope is headed toward a location called the second Sun-Earth Lagrange point, roughly 1.5 million kilometers away, a gravitationally stable spot where Webb also currently operates, chosen specifically because it lets a telescope stay in continuous, unobstructed darkness, without Earth or the Moon repeatedly blocking its view. Getting there, unfolding its components, and beginning full science operations will take months after launch, not days. It's genuinely rare for a NASA flagship mission of this scale to arrive ahead of schedule. Large space telescopes are far more commonly associated with delays measured in years, sometimes decades, than with launch dates moved up by the better part of a year. Roman's team has attributed the accelerated timeline to disciplined engineering execution rather than any shortcuts in testing, and NASA officials have described the observatory as complete, fueled, and ready to fly, well ahead of the original May 2027 launch commitment. In just over a week, a telescope built partly from recycled spy satellite optics, named after a woman who spent her career arguing that space telescopes were worth building at all, will leave Earth aimed at almost 1 billion galaxies and at more exoplanets than humanity has confirmed in the past 30 years combined. Beyond what you can see, but never beyond what you can understand. Subscribe and check out the rest of the channel. New episodes on space, physics, and the edges of what we understand, with new content going up every day.